All right, class. Today we're going to be talking about Chapter 5, Lesson 3, Probability of Compound Events. Now, you're going to need the following materials. From your workbook, you're going to need pages 391, which looks like this, and you're going to need only the first two pages, 391, 392, which is the back right here. We'll also be doing notes on page 393 and page 394. You'll be doing the got it's and the guided practice. You will also need a piece of Cornell note paper because you will be answering some DOK questions, the kind we practiced doing last week. Now, once you have your Cornell note questions, I'm going to go ahead and give you the setup now for your Cornell note paper. Now, you need to have on the top where it says topic objective. Today's lesson is chapter 5-3, pages 391 to 394. Probability of compound events is the name of the section. Our essential question, I changed it a little bit to make it more, to make it fit better with today's lesson, and it is, how can you make a prediction of a compound event? And by the end of this lesson, you should be able to answer that very easily. Now, the questions we're going to be listening to, or listening for the answers during my lesson, are over here on the left-hand side under questions. The first one is, what is a compound event? This is a depth of knowledge question number one, very low level. Just give me the definition or your own definition, which would probably be easier for you to write. Now, when we get to example one in the notes, here's the question that you need to be able to answer by the end of it. How do you know you have listed all possible outcomes? So when we're dealing with compound events, you need to be able to figure out how you will know if all possible outcomes have been listed. On our first got it, letter A, I'm going to ask you to create a tree diagram that goes with that scenario, and when we get to the notes, you'll see what we're talking about. And then down here, overall, through this whole lesson, how would you list the sequence of steps to determine probability for a compound event, or just any event, really? And there's going to be three main steps you need to listen for during the video lecture. So without wasting any more time, let's go ahead and move right into the book. At this point, hopefully, you guys will have turned to page 394 in your notes. Excuse me, 391 in your notes. And the topic is probability of compound events. We're going to start in the very beginning with the real-world lesson. Here it says, Amy wants to pack enough items to create 6 different outfits. She packs 1 jacket, 3 shirts, and 2 pairs of jeans. Can Amy create 6 different outfits from her clothing items? So, number 1, create the table below to list the sample space. Remember, a sample space gives us all possible outcomes of any given event, or events in this case. Now, we want to see if she can make outfits, or how many she can make. We know that she only has 1 jacket. We're going to assume maybe that she has to wear this, she only has 1 jacket and she has to wear it every day because it's really cold wherever she's going. And that's no big deal. Most of us have maybe 1 jacket we prefer to wear most often. And then now she has 3 shirts to choose from. So we'll pretend she has her most favorite shirt, maybe her second favorite shirt, and then her least favorite shirt. And then she has 2 pairs of jeans. Her best fitting jeans maybe, and her second best fitting jeans. So we want to know all the sample space. We want to know all the possible outcomes she can make, or in this case, possible outfits. So she can wear her jacket, of course. We know she can wear her jacket every single day, so we write that down in every column. Now, we know she can wear either her first shirt, or her second shirt, or her third shirt. After she picks one of those shirts, she can either wear her first pair of jeans or her second pair of jeans. So in this example up here, she picked her first shirt, her favorite shirt, and her favorite jeans. Then she could have picked her favorite shirt with her second favorite pair of jeans. Maybe she picked her second favorite shirt and then her favorite jeans, or second favorite shirt and second favorite jeans, so on and so forth. Your job is to complete the rest of this list down here. Moving on. Number 2, the table above. So it says list. You can also call it a table. The table is an example of an organized list. So remember, those 2 things are interchangeable. What is another way to show the different outfits that Amy can create? Now, there's something we did in the very, very beginning of this chapter, and that was a very specific kind of diagram. If you recall it, that's the name you can use, or that's the kind you can use. Number 3, let's describe another situation for which you may want to list all possible outcomes. Now, I'm just thinking a little different here, and I'm going to go ahead and give you the solutions to everything. If you created this list correctly, here's the missing pieces you would have had from the list or from the table. A tree diagram is something we've already done, and you will be making those today and in this lesson, so just be ready to do that. And then here's an example of when you might want to list all possible outcomes. For example, maybe you want to know the number of lunches you can make if you're choosing between a certain number of salads, sandwiches, and desserts. That'd be nice if we got dessert, but that doesn't happen too often here. So let's go ahead and move on now to the next page. Page 392, the back of this. Now on the top, it says we have a word highlighted. That means we have a new word, vocabulary word, and the word is a compound event. Compound event consists of two or more simple events. Basically, if you have two or more things happening, it's a compound event, period. The sample space of an event is the set of all possible outcomes. Organized lists, tables, and tree diagrams can be used to represent the sample space. And we will be practicing using all three of those methods. You have to because they're interchangeable, and sometimes some methods work better than others or are quicker than others. So without further ado, let's go on to example number 1 now. Example number 1 reads, the 3 students chosen to represent Mr. Baldrick's class in a school assembly are shown. All 3 of them need to sit in a row on the stage. Use a list to determine the sample space for the different ways they can sit in a row. Remember, a sample space is just a list of all the possible outcomes. So here's the 3 students, Adrienne, Carlos, and Greg. We're going to use initials for each one of these students, A for Adrienne, C for Carlos, and G for Greg. Now we can only use each letter exactly one time because everybody can only go one time in any given order. Adrienne can't sit next to herself, and neither can any of the other students. They can only sit next to a different student in a different order. So we have Adrienne, who can sit with Carlos and then Greg, or we can switch up the 2 boys at the end and then put Adrienne first and then Greg and Carlos. Or suppose we start with Carlos first, as we have in these 2. Then his other choices are either he sits right next to him are either going to be Adrienne or Greg, and then whoever's left over goes in the 3rd spot. Finally, Greg might be the person who decides to be seated first, in which case either Adrienne or Carlos would go next, and then whoever didn't go the first 2 times, the remainder would go at the very end. So out of 3 students, we have 6 possible outcomes. Because after 3 students, we have 3 students to choose from, we pick one, that leaves us with 2 more students. And after those 2 get picked, we're down to 1. So we go from 3 choices to 2 choices to 1. That's very, very important for our essential question overall that we'll get to at the end of this lesson. Now, let's go ahead and look at example number 2. A car can be purchased in blue, silver, red, or purple. It also comes as a convertible or hardtop. Use a table or a tree diagram to determine the sample space for the different styles in which the car can be purchased. Now, in this example, they gave us both, and that's great because sometimes you may not know which one to use in this lesson, and this way you can always come back to this video if you're not sure what a table should look like or what maybe a tree diagram should look like. Now here's what they give us. The first options they give us are the choice of color, blue, silver, red, or purple. These options could also be the events, the color type. We're going to choose a color, so that would be the event. So we have 4 possible outcomes of this first event: blue, silver, red, or purple. None of these can happen at the same time, so that's why they're all separate in this first row. Now, the next choice we have is either we can get a convertible or a hardtop. So every color has 2 choices, convertible or hardtop, and we see that repeated going down this tree diagram. So in total, we have 4 color choices, 2 kinds of tops to give us a sample space of 8 possible outcomes, and that's what's listed here. These are abbreviations but for the colors and for the kind of top. Likewise, over here in the table, once we knew that, we said, okay, we can have either a blue convertible or a blue hardtop, silver convertible or silver hardtop, and we just basically took each color and then the kind of top option that we had until we had our complete list. Now, we know that we've listed all the possible outcomes here, or in any situation, once we have all the possible events or all the outcomes are listed equally. All possible choices have to be able to happen or occur equally and evenly, and happen at least, and can only happen one time. I can't have any repeats. I can't have a blue convertible here and then another one down here for whatever reason. So every possible outcome only happens one time. That's how I know I've listed everything. Now, our first got it down here on the bottom. It says the table shows the sandwich choices for a picnic. Determine the sample space using a list, table, or tree diagram for a sandwich consisting of one type of meat and one bread. So how many sandwiches can you make, basically is the question. If you're given two choices of meat and you can only use one at a time, you can't put both on one sandwich, and you can only have one kind of bread. We're not going to be mixing, I guess, the bread in this case. Well, to help you out a little bit, I'll give you the answer. Here is the list. You can have a ham with rye, or a ham with sourdough, or a ham with white bread. Or you can have a turkey on rye, a turkey with sourdough, or a turkey on white bread. And I think most of you guys already could figure that out. My question goes back to your Cornell notes, and this is the third thing that's asked, and that is to create the tree diagram. I want to see you guys make a tree diagram, kind of like the one above here, but using this information about the sandwiches. So you're going to put that in your Cornell notes as part of your assignment today. So let's go ahead and move on now to the next page. On page 393, we are going to go ahead and look at how do we actually determine probability. And it's a really easy sequence of events that we have to do, and most of you have been doing it already. But now we're going to formalize it for the sake of your notes. So to read from the book, it says, the probability of a compound event, just as with simple events, is the fraction of outcomes in the sample space for which the compound event occurs. And that sounds complicated, but here's what it means. Basically, you have to know what your event or events are. So in example 3, we're going to toss a quarter, a dime, and a nickel. All three of these are basically coins, and all three of them only give me two possible outcomes, heads or tails. So when I flip a quarter, I can get either heads or tails. After I get one of these two, I'm going to flip my dime. Well, dimes also only give you heads or tails. So depending on what I got on the first coin, I will then have to determine what I get from the second coin. After this, I'm going to flip a third coin, the nickel. And nickels, like any other coin, can only give me heads or tails. So I have a quarter, which gives me two choices, a dime, which gives me two choices, and a nickel, which gives me two choices. And I get a total sample space of 8 total choices. And here are all the possible combinations. So the first thing you always want to do is know how many possible outcomes there are from a sample space. You have to create a sample space somehow so you know how many possible outcomes there are. That's the first thing you always have to do. The next thing is you have to know what the question is asking you. In this case, what is the probability of getting 3 tails? Well, the question may give it to you in this word form, or they may give it to you like this in the mathematic notation. P stands for the probability. Whatever in parentheses is the thing we want. In this case, 3 tails. And the more formal way of saying the thing we want is called the favorable outcome. This means this is what we're looking for. We're looking for the probability of getting 3 tails. So out of this sample space that we have created, how many times does 3 tails in a row happen? Only 1 time. So the favorable outcome, which is the thing we want, which is in this example, getting 3 tails, only happens 1 time. 1 time out of 8 possible combinations. No more, no less. We have to also be able to write it as a fraction. I'm also going to expect you guys to know how to write it as a decimal and a percent, because you could be asked to find the probability and know how to represent it in any given way. It's not always going to be expressed as a fraction. It could be expressed as a decimal or percent just as well. But to start, you need to write the probability always beginning with as a fraction or ratio in this case. So the probability of getting 3 tails is 1 out of 8. That would mean, theoretically, if we were to do an experiment and flip all 3 coins 8 times, we would expect to get 3 tails at least 1 time. Although that's the theoretical, in the actual experiment, that may or may not happen, as we all know. So now let's look at got it, letter B. It says the animal shelter has both male and female Labrador retrievers in yellow, brown, or black. There is an equal number of each kind. What is the probability of choosing a female Labrador retriever? Show your work in the space below. So you're going to go ahead and create a tree diagram here. Now here's a little side note they put, and literally it's a side note. When choosing an outcome like they want us to do here, assume that each outcome is chosen randomly. So we're going to pretend that you're basically picking out of maybe a box and you can't see who's in it. You're going to pick up random dog, and here are all the possible combinations. So I'm going to help you out here and give you the tree diagram. All you have to do is recreate it. So the first thing they ask us to do is decide on the gender, male or female. So you can pick either a female or a male, doesn't matter which one comes first. After you pick one of these genders, then you have the possibility of getting all three color combinations of either yellow, brown, or black. So there are yellow, brown, and black females and yellow, brown, and black males. That means there's a total of 6 possible outcomes. They want to know the probability of choosing a yellow Labrador female. So we have female, yellow. There's only one of those combinations out of 6. Here's how you should write it, and here's how it should look. You should have this in your notes for when we grade them, because this will help you when you do some of today's work and ask you to do these kinds of questions. Now, we're almost done with this lesson, so let's go ahead and move on to the final page for this, and that's 394. On the top, we're given a final example. It reads, to win a carnival prize, you need to choose one of 3 doors labeled 1, 2, and 3. How clever, what an interesting carnival. Then you need to choose a red, yellow, or blue box behind each door. What is the probability that the prize is in the blue or yellow box behind door 2? So first thing you have to do is list all possible outcomes. And here they did it in a table or list, however you want to call it. Here we have, okay, you can either have, you have 3 doors, and behind each of those 3 doors, there are 3 boxes. 3 doors and 3 boxes means we're going to have 9 total outcomes. Door 1 could either have the red box as the winner, yellow, or the blue. Door 2 could either have the red box, yellow box, or blue box as its winner. Or door 3 could have the red box, yellow, or blue box as its winner. It depends on what the person who's running the game wants to choose as the winning box or boxes. Now, we're going to say, the question asked, what is the probability that the prize is in the blue or yellow? So we're going to pretend that the prize is in both, blue or yellow box, behind door 2. So we have the blue and yellow box with door 2. That only happens 2 out of 9 times. So the probability that the prize is going to be in one of those 2 is 2 out of 9. If you want to get a better idea what kind of possibility that is, go ahead and divide that into a percent, and then into a decimal, and then into a percent, and that might help you better visualize it. Now, down here, you're going to do the guided practice. You need to make a sample space, either using a list or a tree diagram. And here, I'll give you some help down here. Here's a tree diagram for tossing a coin twice. Here is a list or table of choosing different kinds of sandals in 2 different colors and in 3 different sizes. And finally, over here, we have a question dealing with a spinner. And here is a list they created as well as an answer to a question. So go ahead and write all these down, because these notes will help you with today's assignment. So once you've done all that, you're going to receive a worksheet with only 4 questions. And I'm going to go ahead and show you what that's going to look like right now. So let me go and switch back to my camera. And remember to do your questions. Let me go ahead and blow this up some so you guys can see it. Remember to answer your questions, guys. These were all in the lecture, in the video lecture, so you may have to go back to review or answer in your own words if you think you're very confident with the solution. If you know what the correct answer is in your own words, feel free to write that down as well, but make sure it makes sense. Now, after you've done all these questions, you need to answer your essential question, which is, how do you make a prediction of a compound event? Answer it very short and sweetly down here, but make it concise. Make sure you know what you're talking about. I did choose these questions from the DOK question stems. I kind of reworded them to make them fit. And then now begin to today's lesson. First of all, you're going to have 4 questions on a worksheet. It looks like this. Now, it's a little fuzzy here on the screen, but that's okay. Yours will be a lot clearer because it'll be in front of you. These 4 questions are all based on the stuff you've done either in previous lessons or in this lesson. You're going to be graded on a rubric, and that rubric is right here. And let me zoom in on it. I know there's a lot of copies of it here, so let me just zoom in on one copy. And here, you have 4 problems. In all 4 problems, I tell you what is expected from each one. And you can either get a range from 0 to 25 points for each problem, depending on how much you do. This little piece of paper will be torn out or will be cut and stapled to the top of your assignment and turned in tomorrow in class. If you have any questions, please raise your hand, and we'll see what we can do to help you. Thank you, guys, and good luck.